So in this video, we're going to calculate the concentration or molarity of all the ions present when 4.36 grams of sodium chromate is dissolved in enough water to make a 640 milliliter solution. Sodium chromate is a strong electrolyte, so what that means is that we expect 100% dissociation or complete dissociation. Now, a little bit different than what we've done before. Here we want to calculate the concentration of just the ions, not the compound. So remember, molarity is defined as the moles of solute per liter of solution. But here we're looking for the moles of the ions, not the moles of the whole compound. So here's what we're going to do. We're going to take our 4.36 grams of the sodium chromate and convert to moles first. Cancel the grams of the sodium chromate, so the grams of sodium chromate go in the denominator. Now, the molar mass here, grams per mole, 1 mole of sodium chromate is 161.98 grams. And so what we've done here is convert to the moles of the sodium chromate. Okay, now that we have the moles of the sodium chromate, now we can go look for the moles of the ions that are present. So we start with our moles of compound. And what we're going to do is go find the moles of the ions present. Let's start with the first ion, the cation sodium. So let's convert to moles of sodium, Na+. Let's cancel the mole of the Na2CrO4. Remember these mole-to-mole relationships. You've got the compound, and here we're studying what's inside the compound. So if you look at the compound, we'll notice that for every 1 mole of the compound, there are 2 times as much sodium. So we're going to double the moles of the compound. So now we have the moles of sodium. Let's do the same thing for the chromate. Let's convert to the moles of chromate, and let's cancel the mole of the sodium chromate. Again, when you see this mole-to-mole relationship, you'll see that for every 1 mole of the compound, there's 1 mole of the chromate. Okay, so we have the moles of the species. Let's get that volume. Now, again, be careful. We have 640 milliliters, but we're going to convert that to liters because by definition, our molarity is the mole per liter. Whoops, sorry about that. That's liters. Okay, so now we can go ahead and go get our answers. So the molarity of our sodium ion is the mole of the sodium ion divided by the volume of the solution. Check those units, mole per liter for sodium. And we'll do the same thing for the chromate. Now the chromate, remember we had a different answer for our moles. So there we go. Let's do a quick recap. So we're looking for the concentration of all the ions in solution. That means we're looking for the molarity of those ions. Molarity is defined as the moles per liter. So we needed to find the moles of the ions first. That's what we do right here, by finding the moles of the compound first, and then finding the moles of the ions. We converted our volume to liters, and then we found the molarity of each ion by taking the moles of ion and dividing by the volume of the solution.